Earth might seem huge, but in the context of the universe, it is microscopic. Did you know that there are roughly 10,000 stars for each grain of sand on Earth? In this video, we will be discussing how fragile the Earth is and the countless ways it can go extinct. Let's start off with a bang, literally. 1. Asteroid impact. Asteroid impacts are natural processes that shape the surface of our planet. Large asteroids or comets colliding with Earth can cause catastrophic events, leading to mass extinction. Notable impact events include the Chicxulub impact 66 million years ago, believed to be the cause of the Cretaceous-Paleogene extinction event, which killed 70% of all species on Earth, including the dinosaurs. The energy released by an impactor depends on its diameter, density, velocity, and angle. The more energy released, the more damage is likely to occur on the ground due to the environmental effects triggered by the impact, such as shock waves, heat radiation, the formation of craters associated with earthquakes, and tsunamis if bodies of water are hit. Fun fact, maybe not so fun. In 2029, Apophis nicknamed You Won't Believe It, God of Chaos will come very close to Earth on April 13, 2029. So close it will be visible to the naked eye. The Alvarez hypothesis, which suggests that an asteroid impact caused the mass extinction at the end of the Mesozoic era, is now the most widely accepted theory for the mass extinction of dinosaurs. 2. Supernova explosions. A supernova is a powerful and luminous explosion of a star. The effects of a supernova on Earth depend on various factors, including the distance of the supernova from our planet. The most significant dangers come from the intense radiation, particularly gamma rays and X-rays, emitted by the supernova. These radiation will leave us looking like this, so let's just pray this is not the way out. These high-energy particles can have several adverse effects, such as destroying the ozone layer, causing mutations in earthly life, and altering the planet's atmospheric chemistry, potentially leading to mass extinctions and significant damage to the Earth's ecosystems. It was previously believed that a supernova would have to be within about 25 light-years of Earth to cause significant environmental damage. However, more recent studies have suggested that the damaging effects of a supernova could be felt up to 160 light-years away, particularly due to the potential damage to the planet's atmosphere and the resulting impact on life on Earth. 3. Gamma ray bursts. Gamma ray bursts, GRBs, are high-energy bursts from distant sources that could pose a threat if Earth were in the line of fire, potentially causing significant damage to the atmosphere. This may look like a lightsaber, stare a little too long, and the only light you are going to see is the light from heaven. GRBs are the brightest electromagnetic blasts known to occur in the universe and can originate from the collapse of massive stars or the collision of two neutron stars. The effects of a nearby GRB on Earth's atmosphere include the depletion of the ozone layer, allowing harmful UV radiation to reach the ground, which could have dire consequences for life. While the immediate effect on life from a GRB within a few kiloparsecs would only be a short increase in ultraviolet radiation, the long-term consequences could be severe, particularly if the burst were to deplete the ozone layer. 4. Solar flares and coronal mass ejections. I'm sure many are aware of what solar flares are, those bastards that dare shut down my internet. How else am I supposed to read dating advice from Reddit? Intense solar activity, such as powerful solar flares or coronal mass ejections, CMEs, can have significant impacts on our planet's magnetic field, potentially disrupting communication and power systems. Solar flares produce high-energy particles and radiation that can be dangerous to living organisms. While the Earth's magnetic field and atmosphere protect us from the most dangerous emissions from flares, energetic charged particles and changes in the atmosphere can degrade satellite communications and disturb radio communications. On the other hand, CMEs are more likely to have a significant effect on our activities than flares because they carry more material into a larger volume of space, increasing the likelihood that they will interact with the Earth. When a CME reaches the Earth, its impact disturbs the Earth's magnetosphere, setting off a geomagnetic storm. This can lead to various effects, including the heating of the Earth's outer atmosphere, which increases the drag on Earth-orbiting satellites, potentially reducing their lifetime in orbit. 5. Black hole encounters. The scariest one on the list by far. Don't want to get spaghettified and squashed from top to toe. A close encounter with a massive black hole could disrupt our solar system, but the likelihood of such an event is extremely low. The closest black holes to our solar system are far too distant to have any kind of effect on our solar system. Even a large, stellar mass black hole would have to be closer than Neptune to begin to have gravitational impacts on the solar system, and it would likely be the same case for any black hole passing by the solar system. The odds of a black hole entering the solar system are estimated at 1 in a trillion, making it incredibly unlikely. If a black hole like Cygnus X1 were to stray near the solar system, within a light year or so, its gravity would cause chaos, significantly altering the orbits of the outer planets and comets. The first indication of something unusual happening would be subtle changes in the orbits of the outer planets and comets. By the time the black hole crosses Earth's orbit, the geologic effects from tidal forces will have effectively repaved the planet. The Sun and the black hole would experience a strong gravitational pull towards each other, leading to Earth being torn apart by gravitational forces and then pulled into the black hole. 6. Long-term stellar changes. The evolution of our Sun into a red giant or other changes in its life cycle could have profound effects on Earth. Stellar evolution is the process by which a star undergoes a sequence of radical changes during its lifetime. Depending on the mass of the star, its lifetime can range from a few million years for the most massive to trillions of years for the least massive, which is considerably longer than the current age of the universe. The Sun, a mid-sized yellow dwarf star, is thought to be in the middle of its main sequence lifespan and will remain on the main sequence for about 10 billion years. However, as it exhausts its hydrogen supply, it will leave the main sequence and begin to evolve into a red giant, expanding and cooling at a similar or slightly lower luminosity to its main sequence state. This phase could have profound effects on Earth, including potentially engulfing the planet as the Sun expands onto the red giant branch. Furthermore, passing stars have been found to alter the long-term orbital evolution of planets, including Earth, and modify our climate. Stellar encounters, where stars pass near our solar system, perturb the giant planet's orbits, which consequently alters the orbital trajectory of the Earth. 7. Cosmic dust and debris. Interstellar dust and debris, as well as space junk and re-entering spacecraft, can have potential impacts on Earth's atmosphere and climate. When space debris re-enters the Earth's atmosphere, it can release compositional chemicals, such as aluminium oxide and other metals, into the upper layers of the atmosphere. These pollutants can affect the ozone layer and alter Earth's albedo, potentially leading to temperature changes and unforeseen consequences for the planet's climate. Additionally, a new study suggests that cooling in the upper atmosphere due to climate change will cause space junk in low Earth orbit, LEO, to stick around for longer, increasing the risk of collisions and further polluting the upper atmosphere. The presence of air pollutants from burning space junk in the stratosphere has been detected, and the concentrations of these pollutants are likely to rise with time, potentially altering the atmosphere of our home planet and having detrimental environmental effects. 8. Extraterrestrial events. If you think there are no aliens out there in this monstrous size of the universe, you are huffing some strong, stupid pills. The search for extraterrestrial life, often referred to as the Search for Extraterrestrial Intelligence, SETI, involves scientific efforts to detect signs of intelligent life beyond Earth. This field encompasses various approaches, including the analysis of radio signals and the exploration of exoplanets for potential habitability. The potential implications of contact with intelligent extraterrestrial civilizations have been a topic of speculation and debate. This includes considerations of the ethical, societal, and geopolitical implications of such an encounter, as well as the potential impact on human civilization and the planet. Chimps are 99% human, and we rule like a king while they are stuck in zoos. Think about aliens that are 5% smarter than us, or 10%, or even twice as smart as us. The encounter with them will not turn out the way Hollywood movies did. 9. Space weather events. You probably are thinking, wait, there's weather in space? Hell yeah, there are. Variations in space weather, such as changes in the solar wind, could affect Earth's magnetosphere and create challenges for technology and communication. Severe space weather, caused by phenomena like coronal mass ejections, CMEs, and solar flares, can lead to large magnetic storms in the magnetosphere and upper atmosphere, affecting the performance and reliability of spaceborne and ground-based technological systems. These events can induce extreme currents in wires, disrupting power lines, causing widespread blackouts, and affecting communication cables that support the internet. Additionally, solar energetic particles and the dislocation of the Earth's radiation belts during severe space weather can damage satellites used for commercial communications, global positioning, and weather forecasting. Space weather events have been recognized as causing problems with new technology since the invention of the telegraph in the 19th century. 10. Climate change. How can a crisis video be missing Big Brother climate change? The impact of climate change on Earth's biodiversity is a significant concern, with scientific research indicating that it poses a substantial risk to many species. Studies have shown that rising temperatures and changing weather patterns can push climatic conditions outside of species' ecological niches, potentially leading to their extinction. For instance, the Intergovernmental Panel on Climate Change, IPCC, has reported that a 1.5 degrees Celsius average rise in temperature may put 20–30% of species at risk of extinction. Furthermore, the IPCC has warned that if current greenhouse gas emissions continue, more than a third of the Earth's animal and plant species could face extinction by 2050, with up to 70% at risk by the end of the century. Blah blah blah, just know climate change ain't a joke. I'm speaking to you, China. Well, that brings the end of 10 ways Earth can go extinct. If you have enjoyed the video or learned something new, be sure to hit like and subscribe to open your third eye. Until next time.